Hello class, this video covers section 12.2, Measure of Central Tendency. Let's look at the guided note. Chapter 12.2, Measures of Central Tendency. After studying this section, you should be able to determine the mean, median, mode, and mid-range for a given data set. So we learn 4 types of measures of central tendency. The beginning of the guided note introduced some very interesting facts. Let's read through them. During the average lifetime, Americans average 2 weeks kissing. But wait, there's more. The average number of friends for a Facebook user is 338. The average number of cars an American owns, I believe is during the lifetime, is 12 cars. The average number of times a 6-year-old laughs per day is 300 times. The average number of hairs in a human eyebrow is 550. The average number of years in the lifespan of a citizen during the Roman Empire is only 28. These numbers represent what is the average or typical in a variety of situations. For some kids, for some 6-year-old kids, maybe they laugh less than 300 times a day. But for some other 6-year-old kid, maybe they laugh more than 300 times a day. Just a typical kid, we can say, averagely speaking, a typical kid, they laugh 300 times every day. So those values are measures of central tendency, or we can just say measurement of centers, because those values normally are located toward the center of a distribution. And as I mentioned earlier, in this section, we are going to learn 4 types of measurements of centers. The 4 types of measures of center are mean, median, mode, and mid-range. Let's look at the first measure of central tendency, mean. Mean here refers to arithmetic mean. Okay, let me write it down. Mean here refers to arithmetic. You might heard of other types of means, geometric mean or harmonic mean, but we do not cover those type of means. When we say mean in this course, we refer to the arithmetic mean. And what is arithmetic mean? Arithmetic mean is the average. Yeah, in real life, when we say average, we actually means the arithmetic mean. If you have, let's say, 10 numbers, and what is the arithmetic mean of the 10 numbers? You add them up, and you have a sum. You have the sum of the 10 numbers, and you divide the sum by 10, and that value is the arithmetic mean. So the formula for the mean is this formula, and our guided note explains the notation sigma. The Greek letter sigma means the summation. Yeah, that symbol is the symbol of summation. It means the sum. It means the sum of all the values in the data set. We add them all up and then divide the sum by the number of values in the data set. Then the value is called the mean. Pretty straightforward. I believe most of you already know that. So let's look at the example. This example gives us a frequency polygon. We learned frequency polygon in previous section, right? And the graph shows the percentage of 18 to 29-year-olds voting in 7 midterm elections from 1994 through 2018. We are going to find the mean percentage of youth voter turnout for this period. What period? From 1994 to 2018, that time period. Round your answer to the nearest percent. Okay, let's see what data set we have here. From the graph, we have the data set. 1994, 1994, the percentage is 22%. Let me write it down. 1998 is 20%. 2002, 20%. 2006, 24%. 2010, 20%. 2014, 21%. And the last one, 2018, is 31%. So the graph actually gives us a data set contains 1, 2, 3, 4, 5, 6, 7. 7 percentages. 7 percentages. Let me quickly double check. 22, 24, 320, 121, 131. Okay. We are going to find the mean of those values. Yeah, special thing about those values are in the format of percentage. So we are going to find the mean of those percentages. So we are looking for the mean percentage. Okay, so the symbol, the notation for mean, this is a notation for sample mean. Technically, it's sample mean. Okay, sample mean, because this is a sample. A corresponding concept is called a population mean. The notation for population mean is mu. Sample mean, notation for sample mean is x bar, a lowercase x, and with a bar on top of it. So by the formula, we are going to add all the 7 percentages together and then divide by 7. Right? Since all the 7 percentages have a percent symbol, so I'm going to factor the percent symbol out. And I'm going to add all those numbers together. I have 22 plus 20 plus 20 plus 24. I need more space. I'm on 24. And plus 20 plus 21 plus 31. Okay, I'm going to use a calculator to get that done. I have 22 plus 20 plus 20 plus 24 plus 20 plus 21 plus 31. Yeah, one good thing about TI-84 calculator is you are able to see those numbers. And the sum is 158. So the summation of those percentages is 158%, and we're going to divide by 7. Yeah, we're going to leave the percent sign all the time, the whole process, and only deal with those numbers, the percent points. And divide 158 by what? By 7. Why 7? 7 is the sample size, the total number of the values, right? Total number of the percentages. And I got a decimal. The question ask to run your answer to the nearest percent. So I would have 23%, rounded up. Okay, 23%, rounded up, 23%. That's a very reasonable value, right? Very reasonable value. 23% is around this 25. 23 is around here, you know. Yeah, that shows you why the name is called a measure of central tendency, because normally those values, mean, median, mode, or mid-range, they locate toward the center of the percentages, of the values, in this case the percentages. All right, pretty straightforward example. Only special thing is those values are percentages. And all we need to do is to add them all up and then divide the sum by the number of percentages and then round it properly. Rounding is still important for test 3. Be very, very careful. And what if the data set is not given as a raw data set like this one? Instead, the data set is already organized and it is given as a frequency distribution table. we also have learned the frequency distribution table in previous section, right? For example, this problem. And then how do we find the mean? Let's look at this example. A questionnaire was given to students in an intro-statistics class during the first week of the course. One question asked, how stressed have you been in the last 2 weeks? On a scale of 0 to 10, with 0 being not at all stressed, 10 being as stressed as possible. The table shows the students' responses. Use the frequency distribution table to find the mean of the stress level readings. Okay, so this is an example in which the raw data set is not given. Instead, the corresponding frequency distribution table is given. Now, how do we find the mean, the average? Since those numbers are not very convenient, so I copy the table here and I'm going to process. I'm going to find the mean by using the Excel. What you can do is to have the same table on your scratch paper, but you do not use the function in Excel. You're going to use your calculator. So the first column is stress reading. We can just use X. And second column is frequency, corresponding frequency. The reading start from 0 all the way to 10, right? So we can do this. Drag. Oh, no. I should do control. Try this one. Continue. Yeah, control drag. And this one is not 10. Let me do it again. Sorry about that. So from here, so from 2, then we have 11 numbers. So I'm going to stop at 12. So control drag until 12 here. Here we go. And the frequency, we would have to type the numbers manually. So this is 2. That means what? 2 students. How many students in total? Yeah, if you add them up, let's see if we have the number given from the problem. How many students? It doesn't say, right? Okay, we're gonna figure out in a moment. So in a sample, anyway, you have a sample of subjects, a sample of students. Among those students, 2 of them do not feel stress at all. 1 of them has stress level 1. 3 of them has stress level 2. 12 of them have stress level 3. Yeah, so you understand the meaning. I'm going to just enter those values. So this is 16, 18, 13, 31, 26, 15, 14. It never hurts to always double check your value, just in case you copy anything wrong. Then even your process is correct, you will not have the right answer. So I just quickly look at them. 2, 1, 3, 12, 16, 18, 13, 31, 26. Yeah, that's correct. All right, so that's the second column, right? And in the third column, I'm going to add one more column. It's called the products. Product. So what's our goal, guys? Our goal is to find the mean of the data set, right? So earlier I asked how many people, how many subjects in your sample, right? So now we can find it out by add up those frequencies from B2 all the way to B11. Hold on. Did I miss? Hold on, my bad. So from not B12, close. All right, let me double check. Sum from B2 to B12. So 151. So your sample size is 151. You surveyed 151 students in the class. Okay, so we are looking for the mean stress readings of the 151 students, right? And so this is what we do. We have to find the product first. For each row, we multiply the value with the corresponding frequency. So here, 0 times 2 is 0. So I'm going to use the function A2 times B2. And the second row, 1 times 1, of course, is 1, right? And 2 times 3 is 6, 3 times 12 is 36, 4 times 16 is 64, 5 times 18 is 90, 6 times 13 is 78, 7 times 31 is 217, 8 times 26 is 208, 9 times 15 is 135, 10 times 14 is 140. And you're going to manually get those products and then list in the third column in the table, okay? And then on the bottom, you see I actually also added a row here, right? The row, I take the sum. I take the sum of those frequencies, also the sum of those products. Add all those products together from C2 to C12. From C2 to C12. So here, C2 to C12. Okay. And then how do we find the mean? The mean is going to be the division of the sum of the products and the sum of those frequencies. You see those two values? Yeah, let me highlight. Oops. Okay, so that is C13 divided by what? Divided by this. And the Excel is pretty cool. Oh, that's the mean. Okay, so what happened is you divide the sum of all the products. I explained very clearly how do we find those products for each row, right? And then you add them up, add them up. And this number, I'm going to, how about, fill in the yellow. This number is the sum of the stress readings of all the 152 students. And divide the sum by the total number of students. How do you know it's 151? Sometimes the problem gives you the value. Sometimes it doesn't give you. In the case it doesn't give you, you just figure out yourself. How do you figure out yourself? Just simply add up all the frequencies. Okay, 2 plus 1 plus 3 all the way to 14. Use your calculator. Use your caution. I know those calculations are pretty straightforward and simple. Just the plus, minus, multiply, divide. You have a calculator. But it doesn't mean you will not make a mistake. So always double check your answer. Be very careful. Being careful is a very important quality, right? We have to be careful all the time. So the mean I got is 6.45, 69, 40, 54. Let's see how do we round the answer. Find the mean of the stress level readings. It doesn't say how to round. If we round to how about 2 decimal places, then it's going to be 6.46. If we round to the nearest integer, whole number, and round it down, and that's going to be 6. All right? Yeah, it's going to be 6. Depends on how do we round it, and that's the mean. Almost 6.5, right? So those 2 examples are about how do we find the arithmetic mean or just the mean. Very straightforward. Add up all the values, divide the sum of all the values by the number of the values, and you will have the average. You will have the mean. The second measure of central tendency is the median. Name-wise, a little bit similar with mean, right? But no, totally different concept. The name of the second measure of center is a median. And what is a median? Median is the number right in the middle of a data set. Suppose the data set is sorted. Yeah, let's look at the formal definition in our guided note. The median is the data item in the middle of each set of ranked or ordered data. So you can see the keyword is very important that we make sure that the data set is ordered, is sorted, normally from the smallest to the largest, right? Yeah, once we work on a couple of questions, you would understand what is the median and how do we find the median. It's also very straightforward. Example, find the median for each of the following groups of data. Part A, the data set has 1, 2, 3, 4, 5 values, and we are going to find the median, okay? And very important thing is if the given data set is not sorted yet, we have to do that manually. I know it's a pretty not very pleasant, especially when the numbers when the data set has many values and you sort them kind of like tedious. Excel can do that, but you don't have Excel available during the test. Luckily, both of those two data sets not horribly long. So let's see part A. The smallest value is 84, so put 84 here. And then we have 88, and then we have 90, and then we have 95, and then we have 98, right? Just put them in order. Technically, from the largest to the smallest also work. But by convention, we like to arrange those values from the smallest to the largest. Okay, let me show you how do I find the median, okay? We are looking for the number right in the middle. So I cross out the smallest, the biggest. And then I have 3 values left. And do it again. Smallest, biggest. How many value left? 1 value left. And that value is right in the middle. So median of this data set equals 90. It's simple, right? Part B. Again, in order to find the median, we have to sort those values. And this one's a little bit long. What's the minimum? The minimum, what I see is 7. So 7 first. That's the only one digit. So no 10, no 11. So 13, 15, 25, and then 28, and then 34. There's only one 30s, 40-ish. It's going to be 47. And then the one bigger than 47 is going to be 59. And then 68 and 74. In case we are missing some value or repeated by accident, repeat the same value twice. Let's see what's the sample size of this data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 values. And do we still have 10 values after we sorted the data set? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. Okay, so this time we're going to use the same technique. Smallest, biggest, smallest, biggest. Always go by 2 at a time. Yeah, the smallest, the biggest, smallest, the biggest, smallest, the biggest. And then how many numbers left? 2 numbers left. Then what's the median? Good question. If the sample size is even, then you will end up have 2 values in the middle. And the median would be the average of the 2 values in the middle. Do you remember what is average? Arithmetic mean, right? You add them up and divide by 2. So we have 14 plus 17. That is 31. Okay? Yeah, 28 divided by 2 is 14. 34 divided by 2 is 17. 14 plus 17 is 31. So the median is 31. Knowing 31 actually is not one of the values. one of those values in data set, but it is the median. The median not necessarily have to be one of the values. Same with mean. Mean doesn't have to be one of the values. Like earlier, all the values are whole numbers, but our mean, the mean we got is a decimal. We rounded it to a whole number, but actually it has more values, more digits. Let me see what is this again. Yeah, 6954 is a decimal. Okay, are you clear about how do we find the median? That's how do we find the median. Okay, in the case the data set has a large number of values, then finding the median would be not very pleasant by using my technique, right? Yeah, our book has another method. You need to remember this. N plus 1 all over 2. That formula can be used to find out the median, the location of the median in the data set. Still you have to arrange the values in order first. So let's read the content in the box. If n data items are arranged in order from smallest to largest, the median is the value in the n plus 1 over 2 position. I mean this. Okay, remember that formula, and we're going to use the formula for the next example. In the next example, we do not have the raw data set. We do not have the raw data set. We have 151 data values, but is already sorted, is already organized, and is displayed in the frequency distribution table. Yes, this is a frequency distribution table, even it is by row. The distribution table we have been seeing is by column, right? The first column is the values. The second column has the corresponding frequencies, right? But this is by row. The first row are the readings, 0 stress level, remember stress level, not stress at all, and 10 is as stressed as possible. And the second row are the corresponding frequency. We have 14 students are very stressed. So 2 students are not stressed at all. So this is a frequency distribution table. Then how do we find the median? If the data set is given as a frequency distribution table, median, and it will be difficult for us to use the original use the method that I gave you earlier, right? Otherwise, you have to do this: 2 zeros, 1 1 3 2, and 12 3 1 2 3 1 2 3 1 2 3 1 2, and then you put them in order, and then you do that. But you know this is not very efficient. We have a formula. Remember the formula. The formula is n plus 1 all over 2. N is the sample size, is given 151. 151 plus 1 over 2 is 152 divided by 2. And that gives us 76. 76. That means the median is going to locate at 76 location. Okay, good news is the sample size is odd number. So we would have one number in the middle. As you can see here, if the sample size is odd, this sample size is 5, is odd number, right? We have one number right in the middle, and that number right in the middle is the median. And when the sample size is even, you would end up with 2 numbers in the middle, and you just need to take an average. And our case, n is odd, so make our question easier, solution easier. So we would know the 76th value would be the median. Okay, so let's see how do we find it. You can go from the left, no problem, but I'm going to do from the right, and I will explain in a moment why. So we have 14 values here. We have 15 values here, and that's already 29, right? And we have 26 values here. 29 plus 26, that gives us 50. 55, 29, 26, 55, yeah. And continue, we have 31 values, right? So plus 31, we have 86. What does that mean? That means our median is going to be 7. How do we know that the median is going to be 7? Because we have 86 values in this part, right? And we have 55 values in this part. That means from the 56 value to the 86 value, those 31 values are all 7. And the 76th value is one of them. So the median is 7. And if you can repeat, if you don't understand, if I'm not very clear enough, you can repeat it. I'm going to now do the other side, okay? The reason I start from right side is numbers are bigger. I may be able to get my location sooner. And if we start from the left, that's also okay. Yeah. So we can see we have 2 here, 1 here, so 3. 3 plus 3 is 6. 6 plus 12 is 18. 18 plus 16 is 34. 34 plus 18 gives us 52, right? And 52 plus 13, that gives us 65, right? Yeah. And from 66 value to the next, from 66 to the next, from the 66 value to the next 31 values, they are all 7. And those include the 76 values. So you still have the same, we'll still have the same result. 7 is the median. 7 is the median. You will see some similar problem in your homework. I hope my explanation is clear enough. All right, so that's how do we find the location of the median. So how come we need more than one measures of central tendency? Is a mean enough? Why do we have to learn median? Yeah, what's the pros and cons for each measure of centers? So here we have an example to explain. In some cases, median is better than mean. Let's look at this example. 5 employees in the assembly section of a television manufacturing company earn salaries. So 5 employees here earn the salaries of $29,700, $30,400, $31,500, $32,600, and $33,000 annually. The section manager has an annual salary $105,000. Find the median annual salary for the 6 people. So we include the manager. So our data set has 6 values. So part A is to find the median. Then we need to order them. Who has the lowest salary? So 29. Are those already in order? Good news, they're already in order. So we just copy 29,700, 30,400, 31,500, 32,600, 33,000, and the last one, the manager, 105,000. 6 values, right? We are looking for median. Yeah. Let's use the technique, the first method I introduced, because it's not too much. Smallest, biggest, and we have 2 in the middle, right? And the median is going to be the average of the 2 values. I'm going to use my calculator. add them up and divide by 2. I'm going to add 31,500 with 32,600 and then divide the sum by 2. We have $32,050. That's the median salary of the group, of the company. Part B, find the mean annual salary for the 6 people. Okay, so let's do that. Yeah, I'm going to just narrate the values. Yeah, if you could please get your calculator as well, and we are going to add up the 6 values all together. So 29,700 plus 3,400 plus 31,500 plus 32,600 plus 33,000 and plus the manager 105,000. So my sum is 262,200, and then divide the sum by 6. I got the mean is 43,700. Do you see the difference between the median and the mean? Yeah, both of them supposed to measure the center of the data set, right? How come that is pretty far away? What happened is this data set, we have an outlier. Let me explain what is outlier. Another name for outlier is extreme values. Extreme value. Those two names are interchangeable. What is an outlier of a data set? In a data set, if we have one or certain one or more values, and those values are far away from majority of the values, like either a lot bigger than or a lot smaller than the majority of values, then those values are extreme values or outliers. So in our data set, among the 6 values, we do have one outlier, the manager's salary. As you can see easily, the manager's salary is a lot bigger than those employees, right? More than twice bigger. So if we use mean to measure the center, we will have a overestimated center, because the outlier, the manager's salary, distorted the center. You see what I'm talking about? You are not going to have, as an employee, you are not probably will not get a salary same with the mean. As you can see, all the 5 employees' salaries are a lot lower than those. But the median pretty well measures the center of the data set. Yeah, what happened is mean is very sensitive to outliers. So when the data set has extreme values or outliers, mean is not a good measurement. Median instead is a better measurement, because the median is not sensitive to the outliers. All it matters, the median is the number in the middle, right? Number in the middle. So it remove the possibility that the outliers will distort the center. Okay, so it explained, this paragraph explained what's the why income. When we talk about income, why we use median salary instead of mean. All the 4 measures of centers have their own advantages and disadvantages. And does mean have its advantages? Yes, mean uses all the values, right? And median only focus on the middle of the data set, but mean use all the values. Depends on the situation, we select the proper measure of center. The third measure of center we are going to learn is called mode, M-O-D-E. Different from mean and median, mode is definitely a value in the data set. Mean, not necessarily a value of the data set. Median, not necessarily, especially when the sample size is odd. Yes, it is one of the data set. But if sample size is even, then it's not necessarily be a value of the data set. But mode, yes, mode of a data set is a value in the data set. Which value? The value that has the most or biggest frequency. So this is the definition for mode. Mode is the data value that occurs most often in a data set. Okay, yeah, mode is a value in the data set with the biggest frequency. As you can see in this table, which number has the biggest frequency? 7, right? The biggest frequency is 31. So 7 is the mode. Okay. Let's look at the example and you understand how do we find the mode. We don't have to sort the data when we find the mode. All we need to do is to identify which value has the biggest frequency. Part A, 2 appears once, 4 once, 8 once, 10 once, but 7 twice. So 7 is the mode. So the data set has one single mode. And part B, 2, 1, 4, 5, 3. Every single data only appears once. So this data set has no mode. Yeah, it doesn't have to have a mode. There's no mode in this data set. Part C, 3, 3, 4, 5, 6, 6. As you can see, we have 2 modes, 3 and 6, because both of them have the same frequency too, and the biggest frequency. And when that happens, the data set has a bimodal, is bimodal. Similarly, we have multimodal. I don't know how to spell the word modal. Multi. So this is a bimodal. We have 2 modes. Okay. Well, the last measure of a tendency, a central tendency, is the mid-range. When do we use mid-range? Why do we need a mid-range? We have already have 3 measures of center. When the data set are not distinct, instead, our data set, our data set is continuous. Temperature is a good example. Temperature is a good example. The temperature, if we let X to represent the temperature in a day, the values of X are going to be any value in the interval, right? The temperature doesn't change by jumping only whole number or a few numbers. So in that case, we want to find the median. Sorry, my bad. We want to find the center, right? Yeah, in that case, when the variable is continuous and we want to find the center of the data set, that data set contains all the possible values for X, then we can use mid-range. A mid-range formula is we use the minimum to add the maximum and divide the sum by 2. Okay, so here the example explained how did we get the temperature in practice. The table shows the 10 hottest cities in the US because temperature is constantly changing, is continuous. You might wonder how the mean temperatures shown in the table are obtained, right? Yeah, what is the temperature every time we see on the forecast? How are they calculated? There are central tendency, measurements of central tendency. First, we need to find a representative daily temperature. This is obtained by adding the lowest and highest temperatures for the day and then dividing the sum by 2. So that actually is the mid-range. Okay, that's the mid-range. Next, we take the representative daily temperatures for all 365 days and add them and divide the sum by 365. So we get a mean. That's arithmetic mean. So mid-range formula, minimum plus maximum all over 2. In other words, mid-range is the average of the minimum and the maximum. A important thing to point out is if you learn standard deviation, if you learn the measurement of deviation, you might know there's another concept in statistics is range. Range is the maximum minus minimum. Mid-range is the sum of the maximum and minimum divided by 2. And the formula is very similar and the name are very similar as well. But we're gonna be very clear. Mid-range is a measure of central tendency. Range is a measure of deviation. Very, very different two concepts. And let's see this example. The magazine examined the factors that affect women's lives, including justice, health, education, economics, and politics. Using these 5 factors, the magazine graded each of 165 countries on a scale from 0 to 100. The 12 best places to be a woman and the 12 worst places to be a woman are shown in the table. Let's see. So those are the best places, 12 best places. And those are 12 worst places to be a woman, right? And we need to find the mid-range score among the 12 best countries to be a woman, okay? Mid-range by the formula is minimum plus maximum, or maximum plus minimum, really doesn't matter. And knowing is not minus, okay? Is adding. Numerator is a sum. So the minimum is 87.2. Maximum is 100. Take the average, yeah, or you can just remember the average of the minimum and the maximum, right? I'll leave this for you to calculate. It's pretty, yeah, let's see what is it. 187.2 divided by 2. 93.6. That's the mid-range. Okay, so suppose your 6 exam grades in a course are 52, 69, 75, 86, 86, and 92. Compute your final course grade using the following. The grading scale is the typical 90 to 100 is A, 80 to 98, 89 is B, etc. Okay, so I'm going to just explain the way to find each measure of tendency, and then you do that on your own, okay? Mean, to find the mean of the 6 value, add them all up and divide the sum by 6. Median, to find the median of the 6 values, firstly arrange them in order, and then find the value in the middle. Since the sample size is 6, is even, you're going to have 2 numbers in the middle, and you just need to take the average of the 2 numbers. Mode, I can quickly identify the mode. 86, because 86 has the biggest frequency, right? Twice. And the middle range would be the minimum plus the maximum and then divide by 2. Do you think you can do that on your own? And the last question is GPA. Yeah, let's take time to understand how do we calculate the GPA. GPA is so important for a student, right? GPA stands for grade point average. Is actually a type of weighted mean. Average, right? Weighted mean. And the red part represents states the process of finding GPA. Is one type of GPA, one common used GPA. And firstly, we multiply the number of credit hours for a course and the number assigned to each grade, and then adding those products, and then divide the sum of those products by the total number of credit hours. Yeah, so follow the instruction. Let's compute the GPA based on the information in the table here. So this student, let's say this semester, takes 5 courses. Yeah, let's see what's the student's GPA for that semester, okay? The first course is sociology. The credit hours is 3, and he got 8. That's very good. The assigned number for letter A grade is 4, so we're going to put a 4 here, okay? Yeah. And second course is biology, and credit hours 3.5. He got a C for this difficult course, so we put a 2 here because the assigned number for C is 2. Music, only 1 credit hour. He got a B. B is 3. Math is 4 credit hour math class. He got a B, so 3. English class, 3 credit hour English class. He got a C, is 2. All right. So we are going to multiply. We are going to multiply the credit hour for each course. Multiply the credit hour with the corresponding number assigned for each grade letter. All right, so we're going to do that for each row. So the first row, first course, 3 times 4, 12. So I'm going to add one more column here. I apologize again. So my device is broken, so I cannot really write here. So 3 times 4 is 12. And the second course, 3.5 times 2 is 7. Okay, the product for the course music, 1 times 3 is 3. And the class for math class, 4 times 3 is 12. The last class, English, 3 times 2 is 6. And then we add them all up. Total, you can also add a row, right? You make your own table. Yeah, add them all up. The total of those products, let's see, what is it? We have 2 12, so that is 24. 24 plus 6 is 30. 30 plus 10 is 40. Let me double check. 19, 22, 34, 6, 40. That's correct. And then we are going to divide the sum of those products by what? By the total number of credit hours. So we're going to have a number here, the total of those credit hours. 3 plus 3.5 plus 1 plus 4 plus 3. So that gives us 14.5. Let me double check. So 6.5, 7.5, 11.5. 11.5 plus 3 is 14.5. Yeah, that's correct. So, and we're going to use the sum of the products divided by the sum of the credit hours. That makes sense, right? GPA, each credit, yeah, each credit by credit was your grade in general, averagely speaking. So let's see what is the 40 divided by 14.5. I got a decimal. 2.75, A6, 2069. Yeah, I don't know how do you round it up. We can keep 4 decimal places, and we do 2.75 A6. Probably in reality, you only keep 1 decimal places. Or I would not say that. Depends on institution. Yeah, we can keep 4 decimal places in this case. It's 2.75 A6. That's your GPA. Does that sound good? You will have a similar problem in Pearson. And how do you find a GPA? Make a table like this. All right. Yeah, assign numbers for each letter grades you got, and for each course you calculate the product of the credit hours and the assigned number for the grade, and then you add up all the products and use the sum of the products to divide by the sum of the credit hours for the semester. You will have the GPA for the transcript of this part. the given transcript. That's everything for today. If you have any questions about measures of central tendency, we learned four of those, right? Please feel free to email me, and I'll see you in the next video. Bye bye.